Hello everyone and welcome to my channel. Today in this video we will talk about basics of group theory. Okay, so this video will be confined up to the calculating point groups and doing symmetry operations. Okay, see, many of you have asked me to make videos on group theory. So group theory is itself a very vast topic. Okay, so it is very difficult for me to make a complete video on group theory because that video size will be it will increase a lot. So that's why I have decided to make the video in 2-3 parts. Okay, so I will try to cover as much as portion in this video so that you get a basic knowledge of what this group theory is. And one more thing, that if you watch this video completely, if you watch this series completely, I'm sure that you will be able to solve all the problems which come in CSIR exam from this topic, group theory. Okay, basically CSIR asks you about 6 to 8 marks question from group theory, where they ask about point groups to find out point group in a particular molecule they give you, and they ask you to find out the point group in that. And other type of question is given on the character table, that you have to find out whether different things were there, different things that they ask about, like reducible and irreducible character and all those things. Okay, so we will start from the very basics so that it becomes easier for you to understand. So first we will talk about the point groups. Okay, so before going to point group, we have to understand from where it comes, that point group. So for that we have to understand symmetry operations. Okay, so symmetry operation, what symmetry operation is? Symmetry operation is just like it is a configurational change. Means if you do an operation, if you do something on a molecule so that it forms like it changes its configuration, and the new formed configuration is indistinguishable from the original one. Okay, for example, see, say you have a triangle. Okay, like this. If you have a triangle and I label it with 1, 2 and 3. Okay, and if I rotate it with 120 degree, if I rotate it, then what will happen? It will again come like this only. What happened? This one, if I rotate 120 degree clockwise, and this one will come here, this 2 will go here, and this 3 will go here. Okay, so both these things are indistinguishable if you don't label them. Okay, but I have labeled them so that you understand, okay, this operation has been done. So this is called a symmetry operation, where you do something on the molecule and the uh, newly formed conformation of this will be indistinguishable from the original one. Again, if you will do 120-degree rotation clockwise, then again you will get same triangle, only just the positions will change. Okay, like this. And again, if you do 120-degree, then it will form like it was originally. Okay, so these all are called symmetry operation. So symmetry operations are of different kinds. Like the first symmetry operation is identity. Okay, so identity, and it is denoted by E. Identity is the symmetry operation, like if you don't do anything to the molecule, if the molecule is itself like that only, then it is called symmetry operation. Okay, this is found in all the molecules. All the molecules contain this identity element. Okay, now the next thing is inversion. Okay, so inversion is a symmetry operation. It is denoted by small I, and this is basically and this inversion is basically called inversion center. Okay, inversion center. Okay, so as its name suggests, it will be present at the center of the molecule. For example, let's take a molecule, let's take a benzene molecule. Okay, so if we have a benzene molecule, there is a center in this molecule along which like okay, so it is a center on in this molecule along which, see, this and this both are at same distances from here. Okay, okay, so next symmetry operation is inversion. Okay, so the element means the molecule should have an inversion center, a center of symmetry. Okay, let's check out means how, what is this inversion means. Inversion, as its name itself suggests, that the molecule will invert. Okay, the positions of the molecule will invert from them, from their position. Like, see how, let's take a molecule, benzene molecule. Okay, and I have labeled different carbons as 1 2 3 4 5 and 6, and this small dot here is an imaginary dot. Okay, that is not a carbon, because this is benzene molecule. Okay, and this is imaginary center on in this molecule. So if you will perform an operation, that is inversion, okay, then what will happen? And this molecule will, means this carbon atoms, okay, which I have labeled, they will change their position about this axis. Okay, so what will become, it will become like this. Okay, first I will put like this. Okay, so one was here, but now it will be inverted and it will go to here. Okay, likewise 2 was here, but it will invert and it will go to here, means here. Okay, 6 was here, it will invert and go to here, and here will be 3 opposite to 6, 4 opposite to 1, and 5 opposite to 2. So like this inversion is operated. Okay, because what happened, all the molecules get inverted from their positions about this center of symmetry. Now I have again taken another example here. What it is, it's a octahedral complex. Okay, I have labeled this molecule as A, it can be anything, and here I have denoted these positions as 1 2 3 4. So if I apply inversion, okay, inversion, so what will happen? So this is only possible, inversions and operation can only be possible if these groups, okay, 1 and 3 are same, so that if you invert them, the new formed molecule will be indistinguishable. Okay, I will give you one example also of this. First we will do this inverse operation. So if I do this operation, A will be here only, and it will be like, first I'll draw these things. Okay, so what will happen, 1 will be inverted from here to here, and 3 will go from here to here. Okay, likewise 2 will come here and 4 will go here. Like this 6 and 5 will also be inverted about this center. Okay, so like this inversion is performed, but where it will be there, and how will you find that, okay, inversion is there or not? For that, center of symmetry should be there. Okay, so the basic thing, basic requirement for inversion operation to operation symmetry operation to perform is, there should be presence of a center of symmetry. Like, if I have a molecule, say this is a molecule, okay, and it is cyclobutane type, and if I will ask, is there any center of symmetry, then you will say yes, there is a center of symmetry here. Okay, this is the center where everything is symmetrical about this. Okay, but if I give you another molecule like this only, but I will just change a little bit. Okay, now here is no carbon, here all are carbons. Okay, so there was center of symmetry, but if I will ask you, is here any center of symmetry, you will say no, because here is nitrogen, and if you consider this as center of symmetry, then what will happen, the all the things are not symmetrical about this axis. Okay, about this point, okay, center. So this will not be, these two are symmetrical, but here it is not symmetrical, so it cannot undergo inversion operation, but this molecule can undergo. There are various examples of this inversion symmetry operation, so we will take them afterwards. First we will go to the next one. Okay, so next symmetry operation is rotation, and rotation symmetry operation is denoted as Cn, and the symmetry element is axis of symmetry. Okay, so axis of symmetry should be present there. What this n signifies, I will tell you. So consider like, we have a molecule. Let's say we have a molecule. We'll take example. Okay, BH3. we have a molecule BH3 like this. And if I ask you that is there any axis of symmetry, so first of all you have to check that okay, is there any axis about which if it is rotated, then the molecule will, okay, first we will check out the previous one, that is the inversion. Okay, first thing which we understood first, that is element, that is identity, that is always there in every molecule, so it will have identity here. Okay, next thing we understood, that is inversion, so we will check if inversion is there. So if we'll take boron as the center, is the center of symmetry. See, if you invert this hydrogen, it will come here. If you invert this hydrogen, it will go there and it will go there. So the, if you perform inversion about this, okay, first I'm just giving you so that you understand inversion, like, so what will happen if you do the inversion operation, then what will happen, this hydrogen will go this side, this one hydrogen will come this side, and this hydrogen, this will go this side. So are these indistinguishable, are these same? No. So this is not symmetry operation. Okay, and inversion is absent here, so we cannot say that inversion is there. Now let's check about the rotation. Rotation is like I gave you example earlier, that is the example of triangle. Okay, we were rotating the triangle about axis, so we need an axis about which we can rotate the molecule. So let's take this molecule only. So we have BH3. So can we rotate this molecule and we get the same structure? Yes, if we rotate it by 120 degree. So what will happen? This hydrogen will come here. I will just name this 1, 2, and 3 so that it is easier to understand. Okay. So if I rotate 120 degree clockwise, okay, that is also important, clockwise. So if we rotate clockwise, then what will happen? This hydrogen that was on first position, that will come here. Okay, so this will H1, H2 will go this here, and H3 will come here. So are these molecule identical? Yes, they are same, just the labeling, because we have labeled, that's why we can distinguish, otherwise or these are indistinguishable. Okay, so this is like, again we can rotate it about 120 degree. So if you will do a 120 degree rotation again, then what will happen? H1 will go here, H2 will go here, and H3 will go here. And again if we'll do rotation of 120 degree, then we will get the same molecule. So how many angles we have rotated? That is theta, that is 120 degree. And if we want to find out the value of n, that is here, so n is basically denoted as n is equals to theta upon, sorry, 360 degree upon theta. So for here it will be 360 upon 120, that will give you 3. So the value of n is 3. So what axis we are getting here? It is C3 axis. So the axis here is C3 axis. Okay, now one more axis is there. Okay, I will tell you how. So if I'll ask you, is there any other axis about which we can rotate the molecule and we get indistinguishable thing? So how we will check that, I will tell you. Okay, so we have this molecule which is T-shaped. Oh, sorry, not T-shaped, which is just like your fan. Okay, if you see your fan, so these hydrogens are just like the wings of your fan. Okay, I don't know whether you in your home there is 4 winged fan or 3 winged fan. Okay, but generally all the homes are having 3 winged fan only. So I'm taking that only as example. So if you look at the fan, wings of the fan, the center of the fan is like this boron atom, and all the 3 wings will be considered as this hydrogen. Okay, so what we can do, we can fix this thing, what boron and this hydrogen, we can fix this axis and we can rotate by this. How? Let's see, like, see, let's check, let's consider this pen as the boron and hydrogen. Okay, let's say that the boron is here somewhere and hydrogen is here, and what will happen, one hydrogen is here from this boron and one hydrogen is here with this boron. Okay, if I rotate it by 180 degree, okay, like this, if I rotate, then what will happen, the hydrogen which was, sorry, the hydrogen which was here, when I will rotate, then what will happen, that hydrogen from here it will move to this side, and the hydrogen which was previously here, when I moved it by 180 degree, that is rotated from inside and it came like this. So if I take this as the axis, okay, this as the axis, and if I rotate it by how much, 180 degree, okay, so if I rotated it by 180 degree, then what happened, this hydrogen is shifted here and this hydrogen came here. So this is boron, this is H1, it doesn't move, it was there only, but only these two hydrogens moved, okay. So here it was, the H3 will come here and H2 will go here. So this is the rotation by this bond. You can do that from this also, you can fix these two, and if you rotate, then what will happen, H3 will go here and H1 will come here. Similarly, if you fix this bond, what will happen, H1 will come here and H2 will go there. So for n value, what will happen, theta is 180 degree here, so n is equals to 360 upon 180, that is 2. So this axis is C2 axis, okay. So like this, in this molecule two axes are there, two axes of rotations are there, one is C3 axis and one is C2 axis, okay. So this is the rotation, okay. Let's check more molecules and let's try to find out that how many axes are there, how many fold axes are there. This is called fold, okay. This is two fold axis, C2 means two fold axis, C3 means three fold axis. So if I take an example of benzene molecule, I have already told you that this was the center of the molecule, and if I take this molecule on this paper plane and if I consider this pen as the axis, then what will happen, oh, sorry, then what will happen, if I rotate this pen like this, the molecules will change their positions, okay. So 1 2 3 4 5 6, if I will rotate it by 60 degree, then this molecule will come here, this atom will come here and the positions will be changed. So it will be like this. So 1 2 3 4 5 6, okay, by 60 degree rotation only you will get like this. So both of the things are indistinguishable. You have rotated by 60 degrees, so the value of n will be 360 upon 60, that will give you 6, okay. So this is C6 axis, so this is 6-fold axis. So like this you can find out the n-fold axis in any molecule, okay. Let's take another example which is very famous, that is water molecule, okay. So if I have H2O molecule, so if you have H2O molecule, let's label these hydrogen as 1 and 2. Let's check is the axis. So if I pass a axis from this oxygen, okay, and if I rotate this, how these two are, like V in shape, okay, like alphabet V, okay. If you rotate it, inverted V, okay, these are in. So if I rotate this molecule about this axis, what will happen, these two will flip each other, and but I have to rotate it by 180 degree. So what will happen, these two hydrogens will flip and they will change their positions. So it will become like this, H2 will come here and H1 will come here. So what we have done, we have rotated the molecule by 180 degree. 180 degree means 360 by 180, that is 2. So this is C2 axis. C2 axis means two-fold axis, okay. So in this way you can easily find out the axis of symmetry, okay. Let's move on to the next one. There are many examples for this, and one more thing I'm going to tell you, that to perform symmetry operation and to perform all these things, symmetry operations, and to find out the point groups, first you should know the molecule, the structure of the molecule, the shape and geometry of the molecule. For that you can follow my previous video which I made on how to find. I gave a trick, or I gave a brief description, means brief um, explanation of how to find the shape and geometry of molecule easily, okay. So here is the link for that, you can go to this link and watch that video, okay. That will help you in this video, okay. So next we will go to the, okay, so next symmetry operation is reflection, okay, and it is denoted by this sigma, and the element of symmetry is the plane of symmetry. Okay, so you need to find a plane, a mirror plane about which the molecule is indistinguishable. Okay, so, or in simple words I will tell you that you need to find a plane in which if you cut the molecule you can get two equal, like two equal shapes. Okay, for example, let's take example of a molecule, like say we have already taken, let's take this only, BH3. Okay, so if I have this molecule and if I apply a mirror plane, okay, mirror plane, or I just say if I bisect this molecule about this B and H, so what will happen, this if I cut this molecule like this, it we get two equal, means these two sides are equal. Just like if you are putting a mirror here, what mirror does, mirror produces means same image on it, huh? With same the distances are same in the mirror. Okay, so that's why it is called mirror plane. Okay, because this plane acts as a mirror for this hydrogen. So if you see this hydrogen in this mirror, you will see it here. Okay, so that's why we call it a mirror plane. So a mirror plane is a means it produces reflection of the molecule. Okay, and it is caused by a plane of symmetry. Okay, so you just need to find out a plane of symmetry about which the molecule when reflected it is same. Okay, so here it will be like one more mirror plane will be there. If you put a plane like this, then this hydrogen will be reflected here. If you put a plane like this hydrogen will be reflected here. Okay, so in this way we have reflection plane. So before going further, I must tell you that the reflection planes are of three types. Okay, one is sigma v, one is sigma h, and one is sigma d. Okay, sigma v is vertical plane of reflection, sigma h is horizontal plane of reflection, and sigma d is dihedral plane of reflection. What these things are? See, sigma v is vertical plane of reflection is the condition for this vertical plane of reflection is that the plane contains principal principal axis of rotation. Okay, see, we have already seen in previous example in axis of rotation, like I have told you that the molecule, this BH3 molecule I have taken, it was having two types of axis of rotation. One was C3 and one was C2. Okay, so among which one will be called as principal axis of rotation and other will be called primary axis of rotation. Sorry, not principal, it will be I think primary axis of rotation. Okay, so primary and secondary are there, so it's not principal, it is primary. Okay, so one will be called as primary axis of rotation and another will be called as secondary axis of rotation. The one with more order, okay, and more fold, okay, that will be called as primary axis of rotation. So for BH3 molecule we were having two axes. Okay, one was C3 axis and one was C2 axis. So since it is having more folds, so it will be called as primary axis of rotation, and this was having less folds, so it will be called as secondary axis of rotation. So what sigma v is? Sigma v is called as vertical plane of reflection, and this plane contains this primary axis. Okay, so the primary axis which you are making, that where the primary axis is, if that primary axis is contained in a plane, that plane is called as sigma v, means it is called as vertical plane of reflection. Horizontal plane of reflection is this plane of reflection is perpendicular to the primary axis of rotation. Okay, so this sigma h plane will be perpendicular to the primary axis of rotation. So if your primary axis of rotation is in z axis and this plane is along xy axis, then that will be called as your. Okay, so next is the dihedral plane of reflection. Okay, so dihedral plane of reflection is generally a mirror plane that contains principal axis and it bisects the angle found between adjacent C2 axis. Okay, So I know it is difficult from the definition to understand, so I will try to understand you, I will try to make you understand to you. Okay, so let's take an example. Okay, we have a molecule like this, a, okay, we have a molecule like this. So first of all, there is a first of all, let's find out the number of axes in it. Okay, how many axes we have. So first thing which it has is a fourfold axis. Okay, c4. How? Axis passing perpendicular to this page. Okay, this page, if we pass axis from this a molecule, that, and if we rotate this molecule by 90 degree, what will happen? This molecule will be indistinguishable. Means we are rotating the molecule by 90 degree. That means we have a fourfold axis. Okay, so the principal axis is c4. Where it is passing? It is passing from a. So I am just drawing it like this. Okay, so this is the c4 axis. Okay, this is the c4 axis. Just like that I have drawn. It means that since I cannot draw this on 2D, I'm just telling you that it just signifies that this axis is perpendicular to this paper. Okay, and it passes through a, and this is fourfold axis. That means when you rotate this molecule by 90 degree, you will get indistinguishable indistinguishable that if indistinguishable conformations. Okay, okay, let's check out how like other axes also. Okay, we have one more axis, that is c2 axis. How it is passing? It is passing that axis containing this b, a, and this b. If we have an axis like this, and if we rotate this molecule along this axis by 180 degree, what will happen? This b will go there and this b will come here, so that also will be indistinguishable. Okay, so it is c2 axis. Okay, this is c2 axis. From where it is passing? It is passing on this from this molecule only. Cutting means passing through, containing this b, a, and this b. Okay, so this is one more c2 axis. One more c2 axis is here, as you can say that it will be one more c2 axis. Okay, passing through this b and b. Okay, one more c2 axis is there. That c2 axis is passing like this. Okay, how? See, it is passing only through a, but that is not perpendicular to this plane, that is on this plane. Okay, here it is. So if we rotate this molecule like this, what will happen? This b will go there and this b will come here if we rotate it by 180 degree. Okay, so this will be also like this b will go here, this b will go here if we rotate it by 180 degree, and these b will exchange themselves. So this is also a c2 axis. So now we have three axes here in this molecule. One is c4 axis, that is perpendicular to this paper. One is c2 axis, which is passing through this b, a, and b bond, and other c2 axis is also there, which is passing only through a but from on this paper. Okay, so like this we have three axes. Now let's check how many planes are there. Okay, so first we have three planes. We have like all the three planes are present here. Let's check how. First plane will be the plane which will be passing through like this. Okay, like this. If I put like this, the plane which cut this b, a, and b, it cut all the three molecules and it reflects this b to this. Okay, that will be one plane. And another plane that will be like this, it will cut this b, a, and this b, and it will reflect these b's. So that will be called as sigma v, because I have already told you that the plane which contains the primary axis. So this was the primary axis that was perpendicular going like this, and we have this plane which was, and which was this plane which was reflecting this, another plane like this which was reflecting this, and these planes were containing this c4 axis. Okay, so that's why they are called sigma v. Okay, so sigma v is the plane which is cutting this molecule, this means passing through these three molecules b, a, and b, and reflecting these b, and likewise uh, uh, passing through this b, a, and b, and reflecting these b. Okay, so this is sigma v. Now let's check sigma h. Sigma h will be there. I have told you sigma h is the plane which is perpendicular to the primary axis of rotation. Primary axis of rotation was c4, that was going in this like this. Okay, so that was perpendicular to this plane like this, and if we consider a plane that is this paper only, and it is cutting all the molecules, that is B, all the 4B and this A, that plane and this axis both are perpendicular, because this paper and this pen both are perpendicular to each other. So this paper itself is a plane, it itself shows a plane which is perpendicular to the primary axis of rotation. That's why that plane is called as sigma h. Okay, so like this we found two planes, one is sigma v and sigma h. Now let's check what is sigma d. Okay, so what is sigma d? Sigma d is like, see, if we have a plane, like a plane which is like this. Okay, I'm drawing it like this. Okay, so it is a plane like this. So this plane is passing through A, and it is reflecting this B here and this B here, this B here and this B here. Earlier it was done with this C2 axis. Okay, this C2 axis was doing this, we were rotating this molecule, and this B was going that side, and this B were interchangeable, and this B was interchangeable. But now there is no, we are done with this axis. Now we are checking about the plane. So if I have a plane which only passes through A, okay, then what it will do, it will reflect this boron, this, sorry, not boron, this B here and this B here. Okay, these two B will be reflected in this plane, and likewise these two B will be reflected in this plane. So this plane is like, it also contains the principal axis, because it will be like this, na, like this. So it will contain the principal axis, and it bisects the angles formed by adjacent C2 axis. This is the C2 axis and this is the C2 axis. Okay, so it bisects the angle formed between them. So that's why it is called as sigma d. Okay, so this is the dihedral plane. Okay, and one more dihedral plane will be there like this. It will be there like this. Okay. Okay, so this will be the dihedral plane. Okay, we will come up to more examples, and then it will be more clear to you. Okay, you bear with this, I will tell you in more easier way in this sigma d. Okay, so like this, these are the three planes of symmetry. Okay, and one more thing which you need to keep in mind right now is that okay, so one more thing which you have to keep in mind is that there is a what you call a priority order. Okay, so this is the priority order, that the sigma h means the horizontal plane will be given the most priority, then sigma v is there, and then sigma d is there. Okay, so these are the three like this is the priority order. Where we will use this, I will tell you in the point group. Okay, how we will use this priority order. Okay, so the next one is the rotation followed by reflection in a plane perpendicular to that axis. Okay, this is symmetry operation, and it is denoted by Sn, and the element of symmetry is improper axis of rotation. So see, this is a little bit difficult to understand, but I will make you understand it easier, I mean, in easier languages. See, what you have to do, you have to first rotate the molecule. Okay, after rotation, if you are not getting, if the molecule is not in, like, you don't get the previous confirmation. If after rotation you get the previous confirmation, that means it is having axis of rotation. Okay, that we have already studied, that is Cn. Okay, now if after rotation the molecule is not in the previous confirmation, but if you apply a plane perpendicular to that, okay, perpendicular to that axis on which you have rotated, and then you are getting the previous confirmation, then it is called as improper axis of rotation and Sn. Okay, I will give you example. So now let's say we have this molecule that is trans dichloroalkene. Okay, trans dichloroethene it is. So we have two chlorines, so I will label them as 1 and 2, and I have two hydrogens, so I will label that also as 1 and 2. Now what I'm doing, I'm going to do, I'm applying axis. Okay, axis rotation about an axis, this axis, that is 180 degree rotation. So After 180-degree rotation, what will happen? What will happen is, okay, so I have rotated the molecule by 180 degree. What will happen? Hydrogen this hydrogen will come here and this chlorine will go there. So it will be like this, Cl2 and H1. And what will happen at this carbon? This chlorine will come downward and this hydrogen will go upward. So this will be chlorine and this will be hydrogen. So as you can see, these two are indistinguishable, means these two are not equivalent. So what we need to do now? We need to apply a plane that is perpendicular to this axis. What axis we have applied? This was the axis. Now we are going to apply a plane which is perpendicular to this axis. So I'm just drawing it like this. Okay, so this is the plane. So what this plane will do? This will reflect. This will reflect, and after reflection, after applying this plane, okay, what will happen is, okay, so in this plane what you will see that the reflection of this hydrogen will be here, means this hydrogen will go there and this hydrogen will be reflected this side. So here this chlorine will be reflected here, so this will be chlorine and this chlorine will be reflected here. So this, so now this thing which we got is means similar to what we have started with, but to obtain this we have done two things. We have combined two things. One is the normal axis of symmetry, and then we have applied the plane of symmetry that is perpendicular to this axis, okay, that we call sigma h. So this means that Cn into sigma h, which this will give you Sn, okay. So here the axis was twofold, and the C2 axis was there because we have rotated it with 180 degree, so the n value of n will be 2. So for this example we are having S2, okay, so we are having S2 point group. So this was up to here, this was all about those means different operations and how to perform them. Now we will combine them to find out point groups. Okay, I know the video is going a bit larger, but you have to understand these things because it is very important for you, okay, for CSIR exam. So please watch the video completely. Okay, so let's now understand what point groups are. So a point group is a collection of all symmetry operation that can be carried out on a molecule belonging to that group. That means if I have a molecule which belongs to the point group of C2V, then all the molecules which have C2V as their point group, then all the operations which are corresponding to C2V point group can be operated on those molecules. Okay, so this is just like we are just categorizing the molecules in a particular groups, that this group, the molecule belonging to this particular group can have these type of symmetry operations. Okay, so this is basically a characterizing of the molecules into particular group. Okay, so here we have categorized this in more way, like that is the very low symmetry point groups. Okay, so the point groups having very low symmetry, so for that we have C1, Ci and Cs. Okay, so we will understand all these things. So what C1 means? C1 means it this in for this point group only, the only symmetry operation it has is E, means identity operation. Okay, I will give you one example. Let's take this molecule. Okay, we have a molecule like this. Okay, so we have this molecule. This doesn't have any axis, this doesn't have any plane, this doesn't even have any improper axis. What it only has, it has only identity, that I told you that each molecule will be having this thing. So since it only has identity, that's why the point group corresponding to this molecule is C1. Okay, so C1 is the point group which will give you which will correspond to all the molecules which have only E as the, means only identity as the symmetry operation. Okay, now let's go to the CS. Okay, I'll come back to CI afterwards. So what CS is? CS is the point group corresponding to the molecule which only have a plane. Okay, So these only have a plane of symmetry. Okay, so these type of molecules have only a plane of symmetry. Let's take example. So if I have a molecule like this, okay, I have a molecule like this. Now this molecule only have a plane. Where that plane is, see, first of all check for the axis. Is there any axis? There is no axis. I cannot rotate it along this axis. Okay, means that axis which is perpendicular to this page. No, I cannot. Then is there an axis on the plane, like I can rotate it? So if I rotate, this hydrogen can interchange themselves, but here the chlorine and bromine are different groups, so that I cannot do. So that thing also I cannot do. Now the next thing which I can which I have to search is the plane. Okay, is there any plane? So yeah, okay, so all these four groups lie on the plane, on this paper only. So if I cut this molecule along this paper only, okay, that means I have a plane which is cutting this whole molecule like this. Then what will happen? It has one plane, that is the only plane which is present here along with the uh, identity. Okay, so along with identity which is present everywhere, we have uh, plane also. Okay, so we can apply a plane here. That's why the point group for this molecule is CS. So you have to remember these things, because sometimes these type of question are also asked in gate or CSIR. Okay, so this is this point group belongs to a molecule having only a plane. Okay, next is CI. CI means the molecule which is having only inversion center. Okay, the molecule which only has a inversion center or a center of symmetry. Let's take example. Okay, so I have a molecule like this. So okay, so CLBR. This is Cl and this. Okay, so if I have a molecule like this, what it is signifies that on this carbon the chlorine is coming out of paper, bromine is going inside the paper, and on this carbon this bromine is coming out of the paper and this chlorine is going inside the paper. Okay, so is there any axis of symmetry? No, there is no axis. You cannot rotate this molecule like anything. Okay, is there any plane of symmetry? No, there is no plane. You cannot find any plane which will cut this molecule into two equal parts. Okay, so what we only have a center of symmetry. This is the center along which, if you see that this hydrogen and this hydrogen are like at equal distances, and similarly this bromine is downward and this bromine is upward, so these are at inversion center. Okay, this chlorine is upward and this chlorine is downward, so this point is called the center of symmetry, and the symmetry operation is inversion center. Along with, as you know, this identity is everywhere, so along with identity we have inversion center also, so inversion also. So that's why this molecule, the point group for this molecule will be CI. Okay, so like this we have understood these three point groups which are of very low symmetry. One is when there is nothing, only the identity. When there is only a sigma, means only a plane, and when there is only a inversion. Okay, now let's move forward to other type of point groups. Okay, so next is the point group having medium symmetries, and this point group include CN, CNV, CNH, DN, DND, DNH, and SN. Okay, so these are the types of the point groups which will having medium symmetries. Okay, then there will be the point groups which will be having very high symmetry. Those are tetrahedral, octahedral, and then TH, then TO, icosahedral, I, D infinite H, C infinite V. Okay, so since the video is like the length of the video is very increasing So I will not be including these things in this video. I will be making separate video on this because they need like more explanation, and that video will size will itself will be around 30 minutes or 40 minutes. So that's why I'm not including these things in this video. Okay, so stay tuned for the next video. I hope you like this video, and you can give your suggestions, and if you want to ask something about what I have taught in this video, you can ask me in the comment section. And like it feels very good that you people are liking my videos and all. And one more thing, that few people told me that they are not getting notifications in their like they are not getting notifications for when I upload a new video. So I will ask you guys that all of you, if you are not getting the notification regarding the new video, you can press that bell icon which is adjacent to that subscribe button, so that whenever I will upload a video, you will get notification in your email, or if you are using on your mobile, you will get the notification there itself. So that's it for this video. Hope you like it. Thank you for watching, and do share with your friends. And okay, let's see you in the next video. Bye.